So we're just actually going to start with Eric. Eric, introduce yourself.
Sure. My name is Eric Sauer. I'm the CEO of a company called Decodable. We're a managed stream processing platform powered by Apache Flink and Debezium.
Welcome.
Hi, I'm Fred Patton, a developer advocate at InStream. We have a streaming data application platform.
Hi, my name is Xander. I'm the CEO and founder of Bytewax. We are a Python stream processor primarily.
Hey everybody, Jeremy Burr. I'm a streaming specialist with Amazon Web Services. So I work with Apache Flink, Apache Kafka, on top of the managed services of AWS.
Hi everyone, I'm Julian, and I'm from Atlassian, and we do be streaming, so that's why I got called to be here.
Hi, I'm Rachel. I'm the panel moderator. Okay, so we're going to start with a general question to all y'alls. That's the technical term. And we're going to go in an opposite way coming back. So if you had to bet on one technology or current popular architectural design pattern in the streaming analytics space that doesn't exist in 5 years, what would it be and why?
Honestly, it's a great question. Honestly, to think about this one, I feel like the Lambda architecture might start going down, especially because possibly some of the vendors you see up here with having Apache Flink and these processes that can actually do batch and real time in a single thing. You don't really have to worry about handling those things separately, which is really nice. So that would be my big bet for 5 years from now.
Yeah, I was going to say, hopefully all of our companies are still around, hopefully for all our sakes. But I really don't see any specific technology in the streaming ecosystem going away at this point. I mean, I really look at where, and I'm not a marketing person, but I look at the scope of streaming and see Druid and Flink and Kafka and all these wonderful technologies that are ancillary to it, and I see like a growth. And I think over the next 5 years, we're going to see even more companies as streaming becomes more ubiquitous, more than it already is. So I guess I would reverse answer and say I don't expect there to be any.
Well, I'm really hopeful that the data mesh goes away because I still don't know exactly what it is.
Is there anybody from Next Data in the room?
Yeah.
Okay, good. Go on.
If you know what a data mesh is, please help me out. Now, a little bit tongue-in-cheek, but I guess the other side of that, and maybe to talk about what Julian was saying, is like I do see the lakehouse kind of eating a lot of things, and I think maybe what we'll see in the future is like lakehouse sort of eats a few things, and you actually have more specialized tools, and then one bigger general purpose tool, and you have like a streaming lakehouse. I don't know. Sounds kind of fun, but data mesh dies, and streaming lakehouse is number one.
Yeah, well, I was going to jump on the lakehouse thing because I think with Delta Lake, a lot of times it's really going to be your consumers are going to go straight to the Delta Lake. Your producers are going to go to it, so you're going to be able to really optimize your streaming pipelines inside. Any kind of vector stuff or anything you want to do, it's going to be very easy. RAG is going to be very easy. So I think that's also where I kind of zero in on.
I think, there's got to be a collapse of tooling at some point. I think that there's like this running joke that like the modern data stack thing was like a zero interest, sort of phenomenon. And I think that like the complexity of most of these data platforms, everybody that at least I talk to is looking to consolidate tooling and sort of eliminate. And I don't know that any of those tools go away. I just think that like at some level, somebody goes, I have to manage schemas in how many systems? I have to manage like connectors in how many systems? So I think that moving toward consolidated protocols, like we see a lot of people latching onto things like the Kafka protocol. We see lots of people latching onto like things like Iceberg. And more so than like Iceberg, the Parquet sort of format and the table format, the sort of the pattern and the protocol around it is probably more interesting. So I think that different storage engines will always be a thing, and different compute engines will probably always be a thing for as long as we've been talking about consolidation. Oracle is still Oracle, right? Like there's a big building right over there, where a bunch of people make a lot of money. So like, I think at some level that, there's always this like pump and contract thing that's happening. I do hope that, and I really hope if anybody's still trying to do Lambda, please like let me try and talk you out of it. But I do hope certain patterns go away, but I think it's really going to be about tooling consolidation. And I believe that ETL, ELT, and stream processing is actually one category, and it's one product. It's not 50 things stitched together, sort of aftermarket. I think that's just like a pain in the butt for people.
Yeah, I mean, does it matter where your T goes?
My suggestion is, my position is no. I think that like you want one platform where the T can sort of move, right? You want like a migrating T.
Yeah, I never understood why we had to put a T in a certain place and why it could only stay there. It seems like T could go anywhere.
T can go anywhere.
Anyway, we digress. Yeah, and I did, if you do think of Oracle and you look at those buildings, they look outdated. It's like, can you just change your even building architecture to make it look more modern?
It's the Visio diagram of a
Yeah,
database,
exactly.
right?
And I still think of it that way.
I mean, it's literally on purpose, I think. It's just like,
It was.
let's build our building like the Visio diagram.
And also that airport that's right there is KSQL Airport. Fun fact. Anyway, so my first question is for Fred. So you're building Endstream, which is a new player in the streaming space. What's one area of streaming analytics where you feel the legacy players are dropping the ball? And how are you positioning Endstream to solve the problem better than the giants?
Yeah,
Or
so
the less small?
Yeah, so typically, currently, the real emphasis, especially from legacy systems, are on analytics. And if you're trying to build streaming applications that can do real-time decision-making, that's kind of a bad proposition because you're going to do this processing and they're going to basically send it to a database, and then suddenly it's really not streaming anymore. You've got to go do CDC, or you've got to go query, and so who's got time for that? So what we do is we allow streaming to go directly from whatever the source is and directly to the different endpoints. And I will add one more thing about that. So, and the other key thing is about scale, right? So a lot of times it's redundant data, or, and so being able to basically just, maybe you've got 10,000 listeners, 100,000 listeners, you really just want to basically track the deltas, multiplex them, and basically just send the diffs to whoever your subscribers are. So that's our approach.
Awesome. And my next question is for Jeremy. And we're going to go from small to big. And you're a cheerleader for AWS services, right? Which one of the many?
What's AWS?
What did you
Well.
say?
I said, you said small to big, and I said, what's AWS?
Oh, that's right. I haven't heard of them.
Yeah,
Like,
never heard
yeah, small little company.
Small startup.
Yeah.
Still
So-
operates like a startup.
I think we can probably safely say there's a few different streaming services at AWS. One of the things that I've always wondered is how do you advise customers on which ones to use? Like, what's the, where's a cheat sheet there?
Yeah, and it's a question that we get pretty much all the time, pretty much every day from
Darn it, I'm not
customers.
unique.
I even got that question today, being here. And the way I look at it, and you see this consistently throughout AWS, is we like to give customers choices. You can choose, if you have been running Apache Kafka for years, we have a managed service for managed Kafka, or you can run it on your own with EC2s or Kubernetes or wherever you prefer to run Kafka. You can do it on AWS, or you can do it somewhere else. With Flink, same thing, right? You can run it on EKS. We have a managed Flink service called Managed Flink, managed service for Apache Flink. And that's not everybody's cup of tea, right? If you're new to streaming in general, you might want to use more of a abstracted service like Amazon Kinesis, which is more of streaming storage, but it's not as nitty gritty as Apache Kafka, where you have to really know the configurations and the brokers and all of those other things. With Kinesis, you just have to worry about how many shards or how many units of scale. And I think we see customers who don't want to have to think about Kafka configuration, preferring Kinesis for that reason. So that's kind of where I drive customers, but sometimes it's just a preference of we want to use open source, you can do that, or we don't care, and then the managed services are sometimes the better option.
And I feel kind of bad now after looking at these questions, because I have all these kind of vendor questions that might be a little bit of a softball. And then poor Julian, like you're going to get like, I'm sorry, but how do you balance the needs for real-time analytics, or sorry, real-time insights with the inherent complexity of scaling streaming systems? And have you had any close calls where you're just like, ooh, we probably went a little too far?
Sorry if I look at my phone. I have approved questions, approved answers too. I think for that one, at Atlassian, we manage the complexity of scaling streaming systems by employing a distributed model. So each team pretty much owns what events they want to receive and pretty much where that data ends up in the end, right? So occasionally we do receive a burst of events, like in the case of our team that handles Druid for Confluence analytical data. And we've successfully navigated these challenges without major disruptions, thanks largely to Amazon Kinesis, which has been pretty nice for us, because it provides the elasticity needed to handle sudden spikes in data volume, allowing us to absorb the bursts as they come, even if it's unexpected. Now, this model not only supports the real-time insights, but also fosters innovation and agility across the teams, with the data ownership model, where teams get to decide what data they want and how it gets there and where it ends up. So with that and proactive monitoring for us, it's been really, really helpful. So we haven't really had many close calls necessarily, mainly because of what Amazon has been able to build that really helps us. Not a plug.
Yeah, not at all. Okay. All right, the next one's going to be for Eric, and I'm not going to call you old, but I'm going to call you old. And
I am old. Let's do it. Call me old.
You've been around for a while. What have you seen change from your time back at Cloudera to now? Are there still have we solved any of the problems that were bugging you then? Or are they just the same things in new clothes?
Are you asking me if we've done anything over the last decade or so?
Besides jettison Hadoop from most people's ecosystem. Yeah, that was
ripped out
probably
everything that I helped build, 10 years ago.
I'm not saying that.
I mean, realistically, I think the tech sort of moves and changes, and I've been doing this for a hot minute. I've been doing it for about 30 years. And the last 16 or so have been more on the vendor side, building systems, as enterprise services and stuff like that. I think the problems are the same. The problems, ultimately are I've got data in Postgres or whatever, and I need some slice of that plus some slice from a Kafka topic or a Kinesis stream to wind up in Druid. And that problem doesn't fundamentally change as much as we talk about data meshes and stream processing systems and Flink and Kafka and Iceberg and all these other kinds of things. The problem hasn't changed, and maybe that's the sort of sad thing that hasn't changed. I think the thing that there's always this ebb and flow away from and then back to SQL. There's this move towards general programming languages and then DSLs and then back to SQL. There's all of that kind of ebb and flow. I think the thing that has changed is more the complexity of the organizations. So I think that gone are the days that a Jira gets filed for a core IT team that goes builds a thing for you. And there's been a push towards things like self-service and how much can we push the individual teams that are actually producing or consuming the data, to actually be in control of their own fate. I think that's a good change. And I think the tooling has kind of moved in a similar path which gets into like, okay, so if you don't have somebody who's like a data integration specialist and all they want to do is run like a report on Confluence or something like that, they don't care about schema evolution. They don't care about state restoration. They don't care about distributed checkpointing systems. They don't care about all the stuff that at least 4, if not 5 of us care about. You know, so like, I don't know, it's a complicated answer, but I think that the big thing that has changed is the time, the complexity of the organizations, the time that are willing to dedicate to it, and the amount that they're willing to invest in it. I would argue we should be probably spending less time building clever architectures and more time building stuff that like works 99% of the time and works for us like in the middle of the night when stuff isn't kind of going well and like we got one eye open and the other eye like still in bed or something like that. So the systems are too complex. Most people don't have enormous volumes of data, right? I think that like building efficient, cost-effective systems that work in the cloud, which is like a fundamentally different thing that's changed over the last 20 years, that works for the largest possible population of people who mostly don't care about stream processing and data integration. They care about building applications. And so like that to me is like the fundamental thing. That most people aren't platform people. Does that make sense?
It makes sense, but it doesn't matter where the T is then.
It doesn't matter where the T is. I think that's like a thing. Nobody cares where the T is. They kind of go like, today it's over here and tomorrow it's over there. I just want to put data in Snowflake or Druid. Maybe I want to transform it, maybe I don't. But like, I don't want to make that decision once and have to force every decision I make into that paradigm.
Yeah, that makes
I
sense.
said paradigm, so I'm officially a CEO now.
You are. That's it. Like, we'll just knight you right now.
I'll see myself out.
Now, one quick thing I do want to add in with what you said about companies pretty much giving the ownership model to the engineers and the teams, right? The one thing I do want to note there, please build data governance early. Please. Because having the same button trigger 3 different types of events is not great, because then you don't know which one you should be using in the end. So please build data governance early, no matter if you're small, medium, or large as a company. That's very important.
See, these are one of the things that vendors like try to tell you is these are the things you want to think about early, but at the time you're just like, I just want to move the data from here to there. I don't care about the governance. And then about 15 minutes later, you're like, oh crap, I care about the governance.
You're like, I don't care where the T happens.
That's right. But I do
No,
care.
you're gonna care. It's called consistency.
Okay, so ByteWax. You are all about Pythonic streaming, which is quite unique. What's the wildest thing that you've built that you think? Oops, I didn't make this the active question. The wildest thing that you have seen built that would not been able to be done with the. I don't like the traditional tools, but the non-Python tools, I guess.
The legacy tools, because we're not legacy. No,
Yeah, because Decodable is really legacy.
It's okay, we'll take it.
well, I think that's supposed to be a loaded question where I like give you the pitch on ByteWax. But so
Never. I would never do that.
Yeah. Well, there's tons of cool stuff that's been built with ByteWax. Not all of it I can speak about, but the reason I think there's interesting stuff built with ByteWax is for 2 reasons. One, we chose Python not because it's slow and all those bad things people say about it, but because it plugs into an ecosystem of tooling that supports machine learning and AI. And so there is really cool stuff from companies I can't name, but I will suggest a huge social media company that's private or a aviation and aerospace company that keeps its doors on, that have built really cool stuff yeah. I hope they're not in the room, but they probably know who they are. They've built really interesting things, whether it's recommendation systems or predictive analytics, and we get to be a part of what they built. The other part of why we built ByteWax and why we see some unique things that are different from just moving data to A to B, which is we kind of shot ourselves a foot in a little bit because at the end of the day, people are like, I want to move data from A to B. I don't care where the T happens, whatever. We're like, we care where the T happens because if we can't provide the level of primitives that people want and make it really easy to use, their jobs are really difficult. And so we kind of constrained ourselves in what people do, but as a result, we see really cool stuff. Doesn't really, yeah, I don't know if that answers the question.
I feel like I should.
It's fun. My job is fun because I get to see really cool things built and sometimes take part in helping them build it.
I think that's the best part of working for a cutting edge software company, or even, and all of you guys are at cutting edge software companies, is you do get to see really cool things being built. And you get to make a change in the world that is actually noticeable, right?
Potential. Hopefully it's good. That's out of my control. The other
Keeping doors on planes is a good thing. I'm just going to say that.
The other one that you just like reminded me of that is actually good, and I'm like, this is good. I'm not hurting, adolescent teenagers are not being hurt as a result of whatever's going on. Is the EarthScope Consortium built and I can't say this name, built a real-time earthquake prediction system, an earthquake warning system using Bytewax, which was pretty cool. They also used a lot of AWS stuff in there, MSK and blah, 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 blah.
All right, this is a general question, so everybody's got the chance to do their plug. But streaming analytics has come a long way. But most companies, some companies, there's been companies that have struggled to operationalize it at scale. Maybe they've got problems with like data governance or something. So what's one painful lesson you've learned about streaming in production, and how did you overcome it? And I'm just going to let it be like a free-for-all. It's cage match right now. Go for it.
I guess I can go first. At Atlassian specifically, and on Confluence Data Platform, the team that I'm on, we started our journey with streaming and Druid without checking if, at least trusting that the people that are generating the events are going to stick to that schema in the end. However, as of the past maybe year, we've started moving a lot faster internally, which has been a great thing, but there's been pain points on the side of communication, right? And teams upstream communicating that, hey, we're changing this event to have this specific attribute now, and maybe you don't know about it, but just to let you know. Sometimes that gets missed, right? Especially at a company our size. So for us, a pain point we've had was not understanding if the data that's landing in Druid in the end that ends up powering the customer-facing analytics that you see as a customer, if it's fully perfectly correct, which is kind of a sad thing to say in some ways, right? But for us, when we were first moving from Postgres, like you talked about a little bit, to Druid, we decided that okay, we don't want to spend too much time around ensuring data quality is perfect if we trust that our engineers are going to do their jobs correctly 100% of the time, which we know sometimes 99.999% of the time. So for us, recently we ended up investing in doing streaming with Apache Flink, specifically for data schema, understanding if that data is correct and the attributes are there that we expect, and ensuring that we know when someone makes a change upstream. And we can then make them aware that, hey, was this on purpose? If so, then we need to make some changes downstream for ourselves to ensure that we're still showing the data correctly to users in the end. That's been a thing that was painful earlier, but now that we've started doing this and investing the time into that, it got to the point where it got so good that all of Confluence data pretty much now runs through our pipelines because they saw that it could be beneficial for business and organizational metrics, and ensuring that stuff is exactly as it should be, and no one's changing something with when an event comes out that a page was viewed, that it's going to come the way it's expected, and nothing downstream with the data science is going to be broken. So for us, that's what it has been.
Yeah, I know Eric doesn't have any experience with upstream schema changes being a pain point for anybody.
Oh my God, I live in this world. Anybody wants a diatribe on schema migration and how to do that in a large organization, I've got it for you. You don't want it. But I think that, in this question, there's, to me, a couple of different chunks. There's problems that are related to the actual technology, and I'll speak about Flink because it's the thing and Debezium, it's the stuff that I live and breathe. There's complexity in these projects, right? There's complexity that is inherent. There's complexity that is needless. It doesn't need to be that way, but it is that way for a variety of reasons. And there's a lot of self-inflicted pain of I really, really, really want to force this thing to work a particular way when it's really not designed to work that way. And I think that there's a class of problems that come from that There's organizational stuff like we forgot about data governance, or we forgot about like the impact of GDPR on like state retention and those kinds of things. And we see those kinds of problems. What does it mean to retain somebody's information in a stream processing system that can't like delete effectively state the way you might expect? And then there's problems around like the architectural patterns and like how these systems get used, which is you could do something like this on top of Flink, but you really shouldn't. It's not built for that kind of thing. We've all seen that problem where it's like there's a certain amount of religion that gets encoded in like, well, we have to do X on top of technology Y, and like you get into this really nasty case where certain things don't work the way you would want them to. I would say the biggest challenge, I mean, the organizational stuff, like we can try and guide people on, but like you ultimately can't make that decision for them. Some people are gonna do what they're gonna do. The architectural patterns, again, like you can try and guide them, but like there's a certain point at which like as a vendor, people kind of go like, thank you, but I don't pay you for that. Please stop trying to coach me down a particular path. And so like we're really left solving the critical problems with the underlying technology itself, which is like, for the love of God, like please stop coming up with like really fancy, weird protocol buffer schemas and like all these other kinds of things, and like stop twisting up architecture around how you handle schema migrations and stuff like that. There's like a set of known patterns, and the tools kind of want to work that way. So I would say like fundamentally like Flink and stream processing, and I'll just speak about that. I don't want to project too much. It's basically has all the hallmarks of a database system. And it's not the kind of thing that you download off the internet and just like put into production and cross your fingers. You will lose data, you will duplicate a lot of data, stuff just won't work. And so like I think that people sort of like, especially with data infrastructure, underestimate the complexity of these things, and they kind of like start off on this like really, really tough footing of not thinking about like the day two stuff. Xander and I were talking about this just outside, like job observability and debugging and care and feeding and upgrades and migrations of like all sort of permutations. So I think that like that's, to me, it's like not exciting, but it's literally the problem that everyone makes with every one of these platforms. I don't think it's specific to Flink. I think you can do it with the most mature technology out there. Sometimes Flink does not fall into that category. But anyway, I mean, like, I think that's the thing that I would caution people against.
Yeah, we've actually run into a lot of the same thing with those type of platforms. The complexity, and they want to do really stateful processing, but then they're basically using a stateless pattern that is for wherever you put the T, for that type of ETL, ELT type thing. But if you're trying to do a bunch of massive joins and wondering why you can't reach your latency requirements, then you have to step back and think about, what you're really trying to solve. You're really trying to solve for a particular streaming entity and all the entities it cares about, what is the current state? I mean, you can always also listen to more enriched and derived events. And so where we've gotten a lot of wins, and you're reducing latency, and you're saving a lot of money because it's very expensive and you really don't need all of it. And so we basically also said, okay, if you're doing stateful processing needs, you can use a stateful architecture that is really just going to process your deltas for your particular use cases and just consume the type of data that you need. Really, that's been our main win. We see that all the time.
Yeah, if I can just, one thing that I see all the time, and I think it might be controversial on this stage to say it, but not everything needs to be real time.
Whoa.
And I
Them's fighting words. I don't even.
He just said.
I can't believe
Totally
it.
true.
What are you talking about?
But I work with customers who want to create, in Flink, for example, they want a 24-hour tumbling window. And what is that? That's batch, right? That's not real time. But going back to something I think Eric said a little bit earlier, I really love the idea that it's not a popular idea, but it's choosing boring technology as opposed to the new flashy thing that whatever the latest vendors try to sell you, is really a good thing to consider, especially when you say, hey, do we really need sub-millisecond latencies? The answer is usually no, and you can get away with using something that's been around for 10, 15 years and has been successful. I would say that is really where I see customers going down the wrong path, is looking for that like exciting thing, and then on top of that, trying to do it themselves. Like if you think you can run Flink on your own, there's someone here from Netflix who could tell you that they have teams dedicated to doing it. It's not easy. So using a managed service, if you do choose to use something that's complex like that, I would say is another good thing.
I think that leaves you, Xander.
There's no such thing as batch, actually. It's really slow time. 24-hour tumbling window is just a really slow time. So we get a lot of net new to real time or net new to stream processing folks because of the way we position Bytewax. And so we get to see people kind of stumble through the same, we get to learn with them over and over and over again ad nauseum. And it's interesting, like the thing is that it is a complex problem to solve. You're like, I need things in order, I need it to be right, I need it to get there when I want it to get there, and I also want to distribute it across a bunch of workers, but I don't want to pay the time it takes to send things everywhere. And it gets really, really complex. And you're like, I want to save state, and I want to recover it. And so we get to see people go through the journey, and I think the issue that as an industry we've kind of fallen into, and we at Bytewax like do this on purpose, like expressly, is like expose all of that to the user. But it was to our own detriment because commercialization has been kind of hard. But what I've seen successful is a lot of like higher abstractions, and I think that's one of the key things to think about when you're going into a decision-making process where you're going to like buy, build, or whatever. Is like, how can we add the most value as quickly as possible? And so you see lots of things that wrap up stream processing into like a really high-value thing. Decodable does this. Segment, did this. They still do it, I think, kind of via Twilio. I don't know. Cribble does this. There's so many of these like great tools that like, here's all the value. It's packed in. Get going. Move fast. And they're all built on top of these like really hard problems. And so, stream processing is just still really freaking hard. Like stateful stream processing is still really hard. I don't know. I don't know if there's we've spent 3 years trying to like decide if we can make it easier, and everyone's like, give them SQL, and then they're like, but I just really want to do like a proper if, like I just want to do like a proper
Saying that
if.
SQL can't do that, I don't understand.
Yeah, another whole conversation. And then they end up back in like a different land, and it's like all the abstractions are gone, and it's super complex. And it's like, what Eric said, it's like, we're like imperative, and then we're like DSL, and then we're like SQL, and they're like, no, back to imperative. And like everyone goes through the same iteration loop. And we're like, at the end of the day, it's just really fucking hard.
So I was just told that we don't have any time left, which is too bad because this is just getting fun. But thank you all for coming up here and spilling the tea.